Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is snake in matrix. So in this question, there is a snake in a n into n matrix called grid and can move in 4 directions. Each cell in the grid is defined by the position I into n plus j, where I is the row and j is the column number. So each cell inside the grid can be identified by this formula. So this is the position, and how is that position defined? By this formula. And it is stated that the snake starts at cell 0 and follows a sequence of commands. So we are given a commands array which contains 4 directions. The 4 possible directions are up, right, down and left. It is guaranteed that the snake will always remain within the grid boundaries throughout its movements. So let's say if the snake is here, it can't go to the right because it will go out of bounds. It can't go up, it will go out of bounds. So the next command will either be down or left. In this case it is down, so you don't have to worry of the snake going out of bounds. Final task is to return the position in the final cell after the snake executes all the commands given in the string array. So here if we see, we start from cell 0 and we went right. So from 0 we go to 1. Now the snake is here. Now the next command is down, so we go from 1 to 3. So that is here. We ran through all the commands and the final position is 3. So 3 is the output. Similarly in this case, the snake starts here. We go down 0 to 3. So now we are here. Next we go right. So we go from 3 to 4. We are at 4. And from 4 we go up. So we go from 4 to 1. So we are at 1. So final position is 1. Coming to the function given to us, this is the function name. So this is the size of the grid, that is n into n matrix. And we're given a string array or a string list called commands containing the string commands. Final task is to return an integer representing the final position. Now let's declare the position which is initially at 0 because they stated that the snake starts at cell 0. And now there is no need to form the entire grid and then find the final position. We can start with the cell 0, that is our position, and keep building our output based on the command, and finally we can return this position variable which will be our final position. So we can directly return that as the output. Now let's iterate through the commands given to us. So I start a for loop and I iterate one command at a time. So we iterate through the commands list. Now we have to define the positions based on the commands. There are 4 commands. So here if we see, we start with the right command. From any position, if we go right, we add +1. So from 0 to 1, if we go right, we add +1. Here also you can see from 0 to 1, if you want to go, the difference is 1. From 1 to 2, if you want to go, the difference is 1. And it is mentioned that you can't go out of bounds. And here also from 3 to 4, it is difference 1. From 4 to 5, difference 1. So whenever you're moving right, can be generalized that you can add +1 to this position. So first we check if the command we are iterating through, if command dot equals, checking if the string is equal to the command right, then we can add +1 to our position. So increment pause with +1. Now the next command we can do is the opposite of right, left. So if we are at 5 and if you want to go to 4, you do -1. Similarly from 4 to 3 you do -1. Similarly from 8 to 7 or 7 to 6 or from 1 to 0 you can do -1. So I copy this and paste it here and change the command from right to left. And in this case we do -1. Now the 2 leftover commands are up and down. First let's do up. Here we can see there is up. So from 4, if you want to go up, so what is the difference? So it is 3. 4 minus 1 is 3. How did you get 3? By n. So you can generalize for any position. If you want to go from 8 to 5, you do 8 minus n, which is equal to 5. So 8 minus 3 is equal to 5. Similarly from 3 to 0, if you want to go 3 minus n, 3 minus 3 is 0. Here also if you want to go from 3 to 1, difference is 3 minus 1, 2. How did you get 2? That is n. So if the command is up, you do pause minus equal to n. You can't generalize it by doing a hard-coded value. It will depend on the n value. So when command is up, you subtract it by n. Similarly, when command is down, so if you wanted to go from 0 to 2, so you do, what is the difference? That is 2. How did you get 2? That is n. So 0 plus 2 is equal to 2. Similarly here, if you wanted to go from 4 to 7, 4 plus what is equal to 7? 4 plus n is equal to 7. 4 plus 3 is equal to 7. So I copy and paste it here. So if the command is down, pause plus is equal to n. Now this will happen for all the commands and you'll get your final position. Once you run out of the for loop, you can return whatever is present inside this variable. Here we are iterating through command. You have to check for command, not commands. So this has to be command everywhere. You can't do commands, that is a list, but when you're iterating you get one command at a time, so it's command.equal. Now let's try to run the code. The test case are being accepted. Let's submit the code and the solution is accepted. So the time complexity of this approach is big O of n, where n is the length of the list given to us. The space complexity is big O of 1 because we're not using any extra space to solve this question. That's it guys, thank you for watching and I'll see you in the next video.